everyone, we are the Rovers team presenting our autonomous navigation system. For this project of navigation, we need to develop a vision-based system using ROS, and it was developed to enable the puzzlebot to autonomously detect and respond to traffic lights and traffic signs.
Line detection. We rely on puzzlebot's camera to capture the environment in real time. The first developed code called Union Reflectinians runs on the puzzlebot's control system to instantly detect the line that we model will follow. This now publishes the angular and the linear velocity, as well as the flag indicating whether the line is detected or not. To calculate the error, we primarily use contour detection, area calculation, and centroid analysis. After analyzing the robot behavior in different scenarios, we specify a fixed velocity, and the angular velocity is determined by proportional P controller. It's worth mentioning that the robustness of our program allows us to follow the lines even in the presence of reflections caused by ambient light.
In the part of vision, we have a detection and classification node that processes and interprets traffic lights and signs, publishing topics for traffic lights and traffic signs respectively. For traffic lights, we work with HSV mask and contour detection, following a similar methodology to simply bluff detection. In addition to setting minimum and maximum values, we separated the colors, red and green, to avoid confusion for our robot.
For traffic signals, HSV masks are used to identify regions containing traffic signals, as well as blobs and ROIs to achieve precise signal detection. Different processing cases are considered for each signal based on the region of interest. By processing real-time images, color masks based on the HSV color space are used to identify those regions containing the traffic signals. Color ranges are established for different signals, such as red for stop and blue for turn left, turn right, and ahead. A proportion analysis was made to apply our focus on specific color areas containing the signals. Additionally, the size and dimensions of each signal is verified using specific regions of interest, and this was defined to process and determine the signal type. For each signal, different processing cases are considered based on the region of interest. An example of how it works. This is the case of a stop signal, where the region of interest, which is the containing letter stop, is obtained, and an average value was calculated by obtaining the media, and this value is used to establish a detection of the range based on a distance and light level.
By subscribing to the appropriate topics, we obtain the necessary information for our robot to follow the trajectory and detect traffic signs and lights, as we will see below.
Here we can see a video of our robot following the line and also getting some signals of roadwork and turn left or right. And in the other video, we can see how it follows the traffic signal.
To demonstrate the robot's performance, we have conducted a series of tests under various circumstances. We evaluate detection accuracy under different lights.
On different trajectories with change it turns, and at variable driving speeds depending on each sign of traffic lights. Our system has shown a high detection rate and correct classification of traffic signs in some tests, although it exhibits inefficiency in certain situations, such as the positioning of our traffic signs and lighting conditions specific to traffic signs.
In conclusion, this autonomous navigation project has demonstrated that it's possible to successfully implement the traffic light and traffic sign detection system using vision and ROS. However, we acknowledge that there are still areas for improvement. In particular, there is room to enhance the system robustness against adverse conditions, such as extreme lighting levels or damaged traffic signs. There is also potential to integrate other sensors, such as a LiDAR, to improve the detection and enhance system satisfaction.
Thank you for your attention and for joining us in this presentation.